Alright, in our last video we talked about two different types of end behavior asymptotes. The first was an end behavior asymptote that was a horizontal line. So maybe that was the line y equals 2 or the line y equals 0. And what we found was that as our function went out to its ends, okay, so maybe this was our function that went out to its ends, it approached the line y equals 2 at negative infinity and infinity as it got really, really large. Remember that in the middle it can cross over because we're not really worried about what's going on in here, we're worried about what's going on at the ends. Or maybe it was something that looked like this, where it was running to 0, okay, getting really close to it but never touching it. We also saw some graphs that followed a slant asymptote. So maybe your function looked like this, where we had a vertical and a slant. So as x was getting really big, our y value was continuing to grow, but it was following along this line really close. Or as x went this way, our function was following along this line really close, but never touching it. Well, if you think about the end behavior, and we want to know what's happening at the end of a graph, at the end of a number line, whether it's this direction or this direction, you get some form of infinity. So if we want to consider the limits, or what we are approaching as we get close to infinity, okay, then it's really similar to thinking about the end behavior asymptotes. So we'll make that connection here. So first of all, talking about a limit, remember the limit is what's going on near a number or as you approach a number, but we don't care about what's going on at that actual number. And limits at infinity, that holds true because you can't plug in infinity into an equation. That doesn't work because infinity is not a number, it's a concept. So instead, we just have to think about substituting in really big numbers. And when we talk about really big numbers, I'm not talking about 50 or 100, even 1,000 or 10,000. I'm talking millions or trillions or gazillions, whatever comes next, okay? Think about substituting in really big numbers. Similarly, you can think about the end behavior asymptotes if we know that there is a horizontal asymptote. So remember that was if it was bottom heavy or even heavy. Then, as our function goes to infinity or as our function goes to negative infinity, we're going to approach that number with our limit. If there had been a slant asymptote, okay, so that means that our original function had been top heavy, then we would be looking at a graph something like this, and our limit would be either going to infinity or maybe it's going to negative infinity, so positive infinity or negative infinity. Alright, so if we have a bottom heavy function, so the denominator weighs more than the numerator, then we say the limit as x goes to infinity, or this might be negative infinity, pay attention to what's being asked, alright, is going to be equal to 0. If the numerator equals the denominator as far as their power goes, okay, then the limit as x goes to infinity or negative infinity is going to equal the leading coefficient of the numerator over the leading coefficient of the denominator, just like it did for finding the end behavior asymptote. If the degree of the numerator is greater than that of the denominator, so this is top heavy, then the limit as x goes to infinity, or again, negative infinity, you gotta be careful, is going to either be positive infinity or negative infinity. And you need to consider the slant okay? You got to think about the polynomial that you came out with as a slant asymptote. Let's say your slant asymptote was the line y equals x squared plus 2. Well, x squared plus 2 looks like a parabola opening up. So our function, as the limit went to infinity, would be going to infinity, and as it went to negative infinity, would also be going to infinity. if your slant asymptote had been the line y equals negative x plus 3, well then you've got a slant that looks like this. So my function is going to follow along this curve, and as x goes to infinity, my function is going to go to negative infinity, and as x goes to negative infinity, my function will go to infinity. So the C version, right, your top-heavy functions, require more work. Just like they required work with finding the slant asymptote, they also are going to require a little bit more work in determining is it positive infinity or negative infinity that I'm approaching. So the limit as x goes to infinity of 5x minus 3 over x plus 7, first thing would be to try to simplify if you can, and this one is not going to simplify. So we want to look at the power in our numerator over the power in our denominator. This is going to be even heavy, so my limit is going to approach, limit as x goes to infinity is going to be equal to 5. Okay? The other way to think about that is if I plug in really big numbers. So 5 million minus 3 divided by a million plus 7 is going to be really close to 5. As you start to get to really large numbers, subtracting 3 or adding 7 doesn't impact your final answer. Okay? It's going to be the highest power that really is creating your limit value. Alright, so this one, go ahead and factor if you can. X squared plus 5 is not going to factor. We're looking as x goes to negative infinity. So thinking about top heavy, bottom heavy, even heavy. Bottom heavy, that means our limit as x goes to negative infinity is going to be equal to 0. Again, if you plug in really big numbers, well in this case really big negative numbers, okay, I take a really big negative number and divide it by that same really big number, but it's been squared, that's going to result in a number that is getting close to 0. Okay, and again, by the time you're out at really big numbers or really big negative numbers, subtracting 7 or adding 5 doesn't really do much to impact the value of your function. Alright, the limit as x goes to negative infinity, let's go ahead and try to factor this one. Here we're going to get x plus 5 and x minus 1 over x plus 5, x minus 5. Well, these are going to cancel out, so we don't need to worry about them. Instead, we want to look at the limit as x goes to negative infinity of this function here. Well, we've got x to the first power and x to the first power, so those are going to be even, in which case we're going to just look at their leading coefficients, which we have the limit as x goes to negative infinity of 1 over 1, which is just 1. Okay? Again, think about plugging in really big negative numbers. So here I'm at x minus 1 over x minus 5. A really big negative number, so negative a billion minus 1 over negative a billion minus 5. By the time you're out at a negative a billion, these numbers are not going to matter as much, and we've got a really big negative over another really big negative, which results in a positive 1. Alright, the limit as x goes to infinity here, this top one will factor. We've got x plus 5, x minus 3 over x minus 1. Well, nothing cancels here. So you can either look at it from this version that has not canceled, or you can look at it from this one here. I have the higher power in the numerator than the denominator, which means right now my options for my limit are either positive infinity or negative infinity, and I need to do some work to figure out which one it is. Well, the work that I need to do is to figure out what my slant asymptote was. So this is going to be 1, 1, 2, negative 15. Remember, for a slant asymptote, we don't care about this part, we just care about here. So this function is following to infinity in the same way that the line y equals x plus 3 follows to infinity. Well, the line y equals x plus 3 is a line that's been shifted up 3. So as my x goes to infinity, my y value is going to be following along this line, and it's also going to be going to infinity. Alright, so again, if it's top heavy, you need to do your division, look at your slant asymptote, and consider the limit of this function instead. Alright, so to help us with that, just to remind you of some practice with polynomials, the limit as x goes to infinity of 3x plus 2. So maybe this is what came out as your slant asymptote, okay? Well, as you plug in really big numbers, I'm going to get 3 times a really big number plus 2, and that's going to get to another really big number. The limit as x approaches negative infinity, okay, so this time we're moving to the left, negative infinity of 2x to the third plus x minus 2. Well, negative infinity cubed is a negative big number times 2 minus another big number. This is definitely going to be going to negative infinity. Okay? If you think about this, this is a positive, what I call a disco man graph, right? Something like this is its general shape. So as x goes to negative infinity, my y values are going to negative infinity as well. Okay? This one, 2x to the fourth plus 5x squared minus 7x. Well, it's kind of hard to plug in numbers to this one because you got to do a lot of, like this is going to come out positive, this one's going to come out positive, this one's going to come out negative times a negative, okay? You could think about it through and you'll find out that your limit is going to infinity, even though this is going to negative infinity. If you think about it from a graph standpoint, this is 2x to the fourth and it's positive, so my graph looks something like that. As x goes to negative infinity, my y values are going to positive infinity. Okay, so again, as x approaches either the left or the right, what is your y value doing? If your function had been bottom heavy or even heavy, so bottom heavy there would be a horizontal at 0, even heavy there would be a horizontal somewhere else, okay? As your x values go this way to infinity or this way to negative infinity, your y values are going to converge on the same number that the horizontal asymptote will. But if your function had had a slant asymptote, okay, then as x goes to infinity or as x goes to negative infinity, your y values are going to run to infinity or run to negative infinity. And again, depending on how that slant asymptote was going, okay, that'll depend on how your function is running at its ends.